All right, so remember that this Friday is your first assignment. Assignment 0.0 is due. So if you've been following along on the Gantt chart, you should be somewhere around here. Actually, since there are multiple exercises, you should probably be done with the first two. They're really, really simple. And then what you should be doing this week is drafting a solution to that third exercise. Certainly, you should be able to load up the data from the data file and parsing it out, just like because we've given examples. Certainly, by the end of the day, you should be making an object to represent a transaction for that third exercise. But just make sure that you're not doing all the work on that Friday. Otherwise, you're probably not going to get it done, right? All right, so again, you don't have to follow along on our Gantt chart, but it is a helpful tool. If you have another tool, go ahead and use whatever you're comfortable with. We left it off last Friday with searching and sorting, right? And in particular, what you can do is if it's a built-in type, like an integer, a double, a string, you can just use the default natural ordering, right? If you just have a collection, say in this instance, we've got a list of integers, we can sort them, right? And then we can print them out and see that they're sorted in ascending order. That's the natural ordering, right? If it's an artificial ordering, we don't call it unnatural ordering, but if it's an artificial ordering, for example, I want a different ordering, descending, then you have to define what's called a comparator. A comparator is an object with a name, in this case, CMP int descending, right? That has this compare function, this compare method that takes an integer a and b and returns something negative, positive, or zero, depending on the relative ordering of those things. Every single programming language supports something like this, including C and Java, or C, Java, and Python, right? And all you have to do is put the logic in for this. For example, if A is less than B, then they're out of order, right? Because I want it in descending order. So if they're out of order, then I need to return something positive. Otherwise, if A is greater than B, right, then this is greater, this is less, and that's definitely descending, right? Then they are in order and we return something negative. That something can be whatever you want. You can mash your keyboard and just return something negative. Don't get fancy, don't get weird. Just use -1, +1, and finally 0 for the only other case if they're equivalent, right? And then you can call collections.sort on your collection with that particular comparator. And we saw this in action on, save and whatever. And we see that the first time that we sorted it, it's in ascending order, and the second time that we sorted it, it's in descending order. It's actually a lot simpler than that with more modern Java. What you can do is you can use the comparator class to actually do a lot of the work for you. So for example, if I want, I did this because you might need more logic, complex logic, but I can do the same thing, comparator for integers, right? CMP int descending, right? And I have to use a different name here because I can't reuse the same name as before. And what I can do is I can call comparator dot reverse order. And that will take care of any built-in type, integers, doubles, and strings, and whatever, floats, whatever else that you want. You don't have to have a comparator, by the way, if you don't want to reverse it, because that's the default natural ordering. What about strings? Let's go ahead and create a list of strings, right? And I'll call them names like we did before. And I'll say new array list, right? Oops. Okay, and then we can add a bunch of things to that. Say names Alan, right? Names dot add. Excuse me. Come on, dot add. Kind of laggy on this screen. Sorry. Alan, maybe Alan with an A. All right. Let's go with Chris, Jane, and John. All right. And they're not in order right now, but we can go ahead and sort them. And if we just want the natural ordering, then it's just collections.sort and the names. And then we print it out. I'm going to go ahead and steal this code from up here. Oops. There we go. And let's print out names. Now predict, what should come first here? Who comes first? Alan with a capital A. I would agree with that. Does Alan with a lowercase a come next? Nope. Why? Because it's lexicographically ordered. All the uppercase letters come before all the lowercase letters. So if you wanted to have something where it was ordered alphabetically and you wanted to ignore the case, you could, of course, create your own comparator up here, right? And what would it look like? Let's go ahead and show what it would look like. I'm going to steal most of this code up here, and then we're going to adapt it, right? Well, first of all, it's not a comparator for integers anymore. It's a comparator for strings, right? And I need to call it something else, CMP ignore case, str, whatever you want to call it, right? And it's no longer taking integers. It takes a string A and a string B, right? And now I can no longer use the less than, greater than, equals. I could use the equals, but that would give me something that nonsense, right? It would be comparing something in memory, all right? So how do I compare A to B? A dot compare to, right? B, right? And all I need to do is actually capture that. That's the exact same logic, or that's the exact same pattern as a comparator. It returns something negative, positive, or zero, depending on the relative ordering of that. So I don't actually even need all of that down there. All I need to do is have a result. Int result is equal to compare A to B, right? And then I can go ahead and get rid of all this, right? Now, yeah, we're good. Oh, and then I need to return the result. Return result. That could have all been one line, by the way, right? And so let's go with collections dot sort names and then ignore case, CMP ignore case. Now we're not ignoring case yet, right? There's going to have to be a little bit more code here, but I'm showing you the first iteration of this, trying to get it to work, and it's going to produce the exact same thing as before. That's because internally what this is doing is actually using the compare to method. But there was another one that popped up if you were really quick and read it really quick. What? Ignores, or sorry, compare to ignores case, right? And so we can use that one instead. Now where will that Alan be? Right next to the other Alan, right? Now that's going to be alphabetic order. You could have actually done this a lot shorter too, using that same syntax that I was suggesting before. We're going to get a lot more practice with this when we actually have our own class to work with. But what I can say is comparator, right? For strings, right? CMP ignore case descending. Let's go with descending, so that Alan is at the end and who would be at the beginning? John, right? Is equal to comparator dot comparing, and I think that I could do this. I'm pretty sure I could do this. Yeah, string to upper case. There we go. Now let's understand, that's brand new syntax here. Understand what this is doing. I want to create a comparator that compares two strings. I want to say comparing what, right? Well, there's this function inside the string class called toUpperCase. What will that do to the two strings? It will temporarily make them both uppercase, so that ALLEN for both of those Allen strings is all uppercase. Now does it matter what the case is? No, because they're all uppercase, right? And then I can chain this together. Like I said, I wanted this in descending. I can say reversed. Oops, got to spell it reversed. Dot reversed. There we go. So I can chain these things together. I want a comparator that compares a string using the uppercase method, and then I want it reversed. This should work. I don't know why it's not working. All right, what's the problem? To uppercase, it should be. It worked before. All right. Let's go ahead and get rid of reverse maybe for a second. All right, yeah, we'll do that for a second here. And then let's go ahead and sort them just as before. And we'll get the same ordering where the Allens are together. All right, there we go. There, all right. Darn it. I forget how to do it. It just should simply be reversed. Right? Comparator that imposes a reverse ordering on the comparator. I don't know why that's not working, but whatever. I'll come back to that later on. All right. But it's much more compact, right? You don't have to create this compare method, and then inside that you have to put your logic or whatever it should be. By the way, if we wanted this to be the reversed, right? And let's go ahead and make this into reversed, right? Then what could I do with this result here? Remember, the pattern is something negative if they're in order, something positive if they're out of order, and 0 if they're equal. So what could I have done to this statement right here to flip that? Yeah, just negate it, right? or multiply by -1, but just negating it will work just as well, right? I've got a, there we go. Okay, let's go ahead and get rid of this. Or I guess I lost that variable name, that's why, and it's not compiling. There we go. All right, there. And which one was that? There it is. There it is in descending order, ignoring case as well. So the two Allens are together, and then John comes first. Right. So that's sorting. What else would we want to do with a collection? We would want to search through it. What is the most efficient way of searching through a collection? Do you remember from CS1? There's something called linear search, right? That'll just starts at the beginning and says, is that it? Nope. Is that it? Nope. Is that it? Nope. Is that it? Nope. And if you've got 1,000,000 elements, you're going to end up making 1,000,000 comparisons. If you've got 1,000,000,000 elements, you're going to end up making 1,000,000,000 comparisons. What's faster than that? I thought I heard it. Binary search, right? So let's go ahead and put all of this into the notes so that we have, and start over with a simpler version here. Oops, there we go. All right, so there's sorting, excuse me. All right. Now with binary search, what can I just binary search this array as it is right now? Right? And so if you didn't do binary search in CS1 or you've forgotten about it, here's how it works. If it's ordered, if it's sorted, what you can do is you can say, I'm searching for 8. You can jump to the middle. And if that's the thing that you're looking for, great. Go ahead and you're done, right? That's successful. You got lucky. But if it's not the thing I'm looking for and it's sorted, then if I'm searching for 8 and say that I see here 50, well, 8 is less than 50. Should I even bother looking in that direction? Nope. I should be looking over in the first half because it's sorted. 8 would be over here if it exists. Well, I do it again, right? I go ahead and cut it in half, and I look at the middle element, and I either traverse left or right, right? And you can write your own method to do this, but otherwise, there's one built in here, right? So let's binary search for, say, a key. Int key is equal to, let's search for something that's in there, 5, okay? And collections. Dot binary search. I want to search the numbers for the key. Right? Now, what does this return? Let's read our documentation, RTM. Right? It actually, let's jump down here. The returns the index of the search key if it is contained in the list. Otherwise, it returns something negative, telling you where it would have been using this negative value. So we need to capture that value. Int index is equal to. And then we can ask ourselves if the index is greater than or equal to 0. That means it's a successful search. System.out.println success. Element %f. Let's go with I like printf better. %d is at index %d. End the line. And so we're going to be searching for the key. And a binary search told us that it was at a particular index. Otherwise, it's going to be an unsuccessful search. System.out.printf. Failure, right? No such element. There we go. And I'll just go ahead and end the line there. No arguments needed. There we go. Now predict here what's going to happen. Am I going to be able, first of all, is 5 in that list? Yeah. But am I going to find it? No such element. Why? Well, here's the middle element, 4. Right? Where does it go searching for 5 under the assumption that it's sorted? It searches in the right half of the list. Is 5 over there? Nope. Failure because it wasn't sorted. So I need to always sort collections.sort numbers. Right? And then let's actually print it out to show you what it looks like. System.out. Println numbers, just as before here, right? And run it. There we go. Now it successfully finds element 5 at the index 5. 0, 1, 2, 3, 4, 5, and it's right there. Right? So when you're searching and sorting, if you're going to use binary search, and you have to use binary search on your assignment, by the way, otherwise it will take weeks to execute. You will need to sort it by whatever criteria you are actually searching it for. Okay. In other words, if you sort it and you search it, it's got to be the same pattern here. We use the natural ordering for numbers here, the natural ordering for numbers here. If I had that reversed, right, say, let's go ahead and create a comparator here, comparator for integers, integer CMP int descending is equal to comparator dot reversed order. There we go. I will go ahead and sort it, CMP int descending. Let's print it out and see that it in fact is descending order, but I never changed my search criteria. My search criteria was assuming that it was in natural ordering, in ascending order, right? And so when it goes to search, it looks at the middle element here that says 3. Oh, 5 is larger than 3. It must be in the upper half of this list. And it goes off on a wild goose chase, not being able to find it. So if you're going to sort it with a particular comparator, then that means that you also need to search it with that same comparator. And if you do this, then it reverses the order and it reverses the search. It successfully finds it now at index 1 right there because it's in descending order. Okay? So there is your simple primer, and it works with anything. As long as you can create a comparator for it, you can go ahead and search for it. So search, always use binary search. Right? It is exponentially faster. Right? And if you never did, you might not have done a binary search in 155A because there is no binary search built into the Python language. They always want you to be using lists and dictionaries because everything is hash-based in that language. But you can roll your own and create a binary search function in Python and it will work. Right? All right. Okay. Questions so far? Otherwise, let's talk about classes. I mean, we've talked about classes before in the context of, well, this is the demo class. This was the Hello World class. This was the utils class. What I want to do now is come back to, let's go back to our data over here. What I want to do is I want to come back to our books over here. Right? And let me go ahead and create a brand new class here called book demo. Book demo. And by the way, if you don't like typing and you want a main in your class that you create, go ahead and enable that and it'll auto-generate the code for you with a to-do block that you need to come back and actually do something in your main. Right? So here's my data. Right? Now what we did before is we read this in from a file, right? And we processed it line by line. We ignored the first line because that's not actual data, that's the header data. We converted these things in the instances where it made sense. For example, year was converted to an integer. The rating here was converted to a floating point number, a double. We split out the first name and the last name of the author, et cetera, et cetera, et cetera. But what I want to do now is I want to start asking questions about that collection. For example, what is the oldest book I've read, right? What is the newest book I've read, right? What is the best/worst book I've read, according to the ratings, right? What is the author whom I've read the most, right? Or before that even, let's find all books by Frank Herbert, right? So I want to search it. These are all searching and sorting kind of tasks. Why is the oldest book kind of a sorting task? What if I took all the books and I ordered it according to the publish year, right? Where would the oldest book be? Right at the top, right? Where would the newest book be? Right at the bottom. So it sounds like I don't have to go through and find the oldest book and find the newest book using some sort of linear search where I'm saying, okay, there's a book published in 1950. That one was published in 2020. That's not newer. Published in 1995. Right? That's not older. And then you finally find something, 1908, and that's older. Right? Then you update what you're pointing at here. Right? That kind of a basic linear search. What if I had sorted it though, and I just simply looked at the first book, looked at the last book? What if I had sorted it according to rating? Then I could look at the first book and the last book. What if I had sorted it by author and then did a binary search for Herbert, comma, Frank? And this one is going to be a little bit more complex, and which is why we're going to save it to the end. What I want to do is I want to organize all the books. I want to say this author has this collection of books. This author has this collection of books, right? Et cetera, et cetera. But the very first thing that I need to do is I need a way of talking about a book, right? Now, if you look at the code that we did last week sometime, I forget when it was, where we opened up the this CSV file, we created a scanner, we read line by line, ignoring the first line here. Then we read, for each line, we read the line, we split it out into tokens. We got the ID, the title, the author, the first name, last name, ISBN, average, and then the rest of it, okay? We're going to have to finish that now here in a second. But before we do that, let's think, how am I going to store all this data? This just reads one book, right? I could store this in a whole bunch of arrays, like a book IDs array, a titles array, an author last names array. And so I would end up dealing with like a dozen different arrays. And if I sorted one of them, that means I would have to sort all of them, but based on the criteria of that first one. That sounds like a really, really confusing, daunting task to me. So instead, what I'm going to do is I'm going to define a class that represents a book. You probably did classes in 155A. Java or Python does have a class means to create a class. You didn't do classes in C because, of course, there are no classes in C, but there are structures. Both of these things, classes and structures, allow you to take multiple pieces of data, first name, last name, title, rating, right, and encapsulate them into one object, into one thing, okay? So you don't have to keep track of a dozen different arrays. You just keep track of one array of books. To do that, let's go ahead and create a new class. And I'm not going to put a main in this because this is going to be a data class. And I'm going to call it book because it's going to represent a book. Initially, it's empty here, okay? What I want to do is I want to say what belongs in the book class. What defines a book? Right? Well, we're kind of given the prescription up here, right? A book is a book ID, a title, an author's last name, first name, et cetera, et cetera. Right? So let's go ahead and do that. Let's come over here to the book class and start representing those things, modeling those things. That's the word I wanted, right? So we'll just go ahead and go with ID, book ID, book ID. Right? Now, first of all, what type is book ID? What did we agree on last time? Let's look at this. We said an integer, right? Because that's how we parsed it out of that. Hopefully that they're not too big and everything can fit in a 32-bit integer there, right? Then what else was there? In fact, I'm just going to go, you could put this side by side, by the way. If you have enough real estate on your monitors or whatever, right, then you can go ahead and drag and drop this over here and you can look at two files side by side. I'm not going to do that. I'm going to go ahead and copy and paste it over here to give myself some more real estate on my screen. There we go. And just to remember that it's a book ID, a title, et cetera, et cetera. Right? Eventually, I'm going to get rid of that because this is Cruft. Don't leave that kind of stuff in your code. So what is a title? That's a string. What is an author's last name? String, last name. I'll just leave it as last name for now. String, first name. Actually, before I go on, that sounds kind of icky there, right? That doesn't sound well designed, right? The way we define classes when we've got more than one piece of data that logically like represents one thing, right? Well, what is an author? An author is a person. Right? A person has a last name, first name. Maybe they have a date of birth. Maybe they have a social security number. Maybe they have an address, right? So what I'm going to do is I'm going to put a note here to come back and rethink about this. To do. Should this be another class? Be another class? I'll just leave it like that. Who cares about spelling for now, right? And the answer is, of course, yes. And we're going to do that eventually, right? Otherwise, what is ISBN? We said that that was a string because there are letters sometimes in it. There are hyphens sometimes in it, right? An average rating is a double, and I'll just call it rating. Right? And what else do we have over here? Original publisher. So publisher is a string, right? The original publication year, we can make that into an integer, right? Year published or whatever you want to call it. And then date added. Ooh, that's a good question. The date that I read the book, and if we want to look at the look at it again over here, what it looks like, there, right? 9/27/25. That's a month, a day, and a year. What am I holding up on my fingers right here? 3 things. What should that scream out to you? Make a class, because you've got more than one piece of data. That's one object, that's one thing. You should be making a class to do that. Except, we go back to our engineering question. When you need to represent something or when you need to do something, what's the very first question you should ask yourself? Is it already done? And in our case, yes, it's already done, right? Already done being a local date, right? And this was a date read, date added, whatever you want to call it, right? You do have to bring it in. It's in the java.time library, right? But it's a very, very nice library to use because it takes care of everything for you. You can say, all right, well, from that date to that date, how many days are in between? You're going to have to do that for your project. From that date to that date, how many years are in between, et cetera? Is that data, or is that year a leap year, right? All that kind of stuff, right? All right, that's a pretty good start. Let me come over to my book demo class, and let's just go ahead and create a book now, right? Book B is equal to new book, okay? Oops, and this is a call to what's called a constructor, right? That's a function that will produce a book for you, right? Well, have I given that book any data? System.out.println B. So if I haven't given it any data yet, well, what can it possibly produce here? Just some random number, right? Well, no. If this is the path, unl.soc, the name of the class, and then what do you think this hexadecimal number is? That's the memory address, the Java virtual machine memory address where it's being stored. There's no data in here for me to print. Right? So we have to get data in there somehow. Right? Now what I could do is I could start setting it manually. B.title is equal to, let's go with Frank Herbert stuff, Dune. Right? B.first name is equal to Frank. Right? B.last name is equal to Herbert. Right? And I'm going to have to do this for every single book that I want to create. Is that a good idea? I'm going to have to copy and paste. It's going to end up being like 12 lines of code. I'm going to have to copy, paste, copy, paste, copy, paste. Don't copy pasta. Where should this stuff go? It's initializing book data. So it should belong in the book class. You're going to hear me say this over and over again. And it's going to be a design principle that you're going to have to get used to, right? If it's a book thing, it belongs in the book class. If it's an account thing, it belongs in the account class. If it's a person thing, it belongs in the person class. Thank you. Right? So you just need to design your stuff so that everything that's relevant comes into this book class over here. Okay? And by the way, you don't have to do a lot of code to do this. What this is called, what I was doing earlier was called a constructor. Right? This is a special method that has the same name as the class that you are in. But where's the return type there? There is no return type. Right? Instead, it's because it has the same name, it constructs an instance of a book and gives you back that instance. Right? Now, this is the default constructor. Is there any input into this? No, because it's blank right here, right? All right? That's not what I want. What I want to do is I want to pass in the book ID. I want to pass in the title. I want to pass in the first name, last name, right, et cetera, et cetera. And I want to set those things, right? So let me try. Now, I've got some more stuff to do. I don't like typing, and I'll show you how to save on typing here in a second. But now I want to set book ID to book ID. And it is going to underline this with a yellowish kind of color, indicating that there's not a compiler error here, but there is a warning. The assignment of a variable book ID has no effect. Let me show you what this means. If I said int x is equal to 42, and then later on I said x is equal to x, does that code make any sense? You're just taking the value of x and putting it right back into the variable x. And I'm getting the same warning there, that the assignment of a variable x has no effect. So what is it talking about here? There are actually two variables called book ID in scope right now. There is the parameter variable right here, and then there's this variable up here that belongs to the class. All I'm doing on this line is resetting this book ID. The parameter variable, I'm taking the parameter and putting it back into the parameter. I'm not actually changing this book ID up here. What I need is a better way of referring to that, okay? So we're gonna use pronouns. Now, if I'm a person, I say me, myself, and I, right? Those are my pronouns. What would an object's pronouns be, though? It's not a person, so we don't want to personify it or anthropomorphize it or whatever. We want it to be an object. So what would an object that could talk say that it is? Not me, myself, and I. It's this, dot. Now that does have an effect. This dot book ID is referring to that book ID up there. This book ID is referring to that book ID right there. You can see the ID highlighting them for me. And so I can set the book ID, I can set the title, this dot title is equal to title, right? This dot last name is equal to last name. I hate typing. So let's go ahead and get rid of this. And let's go up and let our IDE do our work for us. This is not AI. This is something that's been in IDEs for 50 years or whatever. Not 50 years, but a good 30 at least. Let's go ahead and generate a constructor using fields. I want all those things in there. If you didn't want all of those things, like you didn't care about the rating or something, you could go ahead and declick that or unclick that, whatever you call it, right? Unclick that, right? I'm going to select all, and I'm going to generate. Great, it did all the work for me, okay? And now I don't have to do all that work over here in the book demo, okay? What I can do is I can pass in the values. I don't know what the book ID here would be, so 1, 2, 3, 4, right? And then it would be Dune by, and then what was it, first name or last name? At this point, I am going to split screen this because, come on, there we go. I don't remember the ordering, right? There are better ways of handling that, by the way, too. So there's Herbert, so Dune, then Herbert, Frank, what else is there? ISBN, I have no idea what that would be, so I'll just make something else up there. The rating, 4.5. Not the greatest, but not perfect. Not the worst either. Publisher, I have no idea. Publisher, I'll just leave that as publisher there. What year was it? I think it was 1950s something, or 60s maybe. Let's go with 1960, whatever. And then local date here. All right. How do I create a local date that I read it? Okay. Well, that is a class in and of itself. Come on. All right. It is letting me type. There we go. I need to create a local date here. So let's do that before we even create a book here. Local date. Now, if I was creating this like my book class, then what I would do is I would say the date is equal to new local date, and then pass in the date, month, and the year. Unfortunately, they chose not to, fortunately or unfortunately, depends on your point of view, they designed it a different way. They designed it with what's called a factory function, okay? So it's not a new local date because there is that is not available to us. Instead, it's local date.of, and then you can provide it the year. Let's say that I read it in 2020, January 15th. There we go. That's how you can create dates there. Right? It's local date.of, and then it's a factory function inside that there is a constructor call somewhere that is calling a constructor and passing in those three variables. But otherwise, it's doing it for us. Right? They just decided that they wanted a different way of creating local dates. Right? It was just a design decision based on what they were feeling at the time. I'm sure that there was some sort of a back and forth on what the best design is. In fact, that's what you'll be doing. On Monday, a week from now, we will be talking about the technical writing with the Writing Center coming in, because you're going to have to, next week, you're going to be drafting your first draft of your design document. And you'll be talking with your partner or whiteboarding ideas and going back and forth. What classes should we have? What variables should each one of those classes have, et cetera, et cetera. And so you'll be having those same discussions of, should we have a constructor or should we use this kind of factory method instead, right? Use a constructor, don't get fancy, right? All right, so there's my first book, right? Let me go ahead and run this and see if it works. Just as before, right? In fact, was it the exact same, it's the exact same address every single time. That's just because the Java virtual machine is loading it up in the same address every single time. I want it to be a little bit more human readable. To do that, I need to add more functionality to my book class, right? To make it more human readable, you can make a public string toString method. In fact, the default behavior of this toString method is to return what you see right here, a fully qualified path name along with a memory address, right? If you want it to look like something else, then you need to program it to look like something else. Let's return a string that is the this.lastname plus this.firstname with a maybe comma between them, a comma, space. Oh, and then I guess the title is the most important thing, right? This.title plus, and then a space there, or by, there we go, and then concatenate all that stuff together, right? So I've chosen to format this so that it's title, by, last name, comma, first name. When I run this, my book demo over here now, right? Dune by Frank Herbert, comma, Frank, right? I, of course, could have printed out a whole bunch of other stuff, like, say, the rating, the publisher, whatever. I just want to go with this for now, okay? Maybe we'll do a little bit more later on, and all that means is that we come back over to the book class and update this method right here, right? Formatting a book sounds like a book thing. Where does it belong? Right here in the book class. Just repeat that over to yourself when you're designing your own classes. I have this piece of functionality. Well, that piece of functionality is a X thing. It belongs in the X class. Right? That's how you should be organizing your code. Right? All right. Well, now at this point, what I could do is I could cut and paste this stuff. I'll do it for you next time, but cut and paste this stuff so that we're creating a whole bunch of books from that data. For now, though, what I want to do is I want to look and see what are the implications or what are the consequences of the design that we have so far. If I wanted to create another book, B2 here, new book, but I didn't want to specify anything, remember that worked before. It no longer works now. And that's because there is no constructor with no arguments over here anymore, right? There wasn't before, but the Java provided one for me. By default, it's kind of like a lawyer, right? If you can't afford one will be provided for you, free of charge. Well, if you don't write a constructor, one will be provided for you free of charge by Java. It's the no argument default constructor that doesn't take any data and doesn't do anything, right? Other than initialize these things to nulls or zeros, right? And now over here, I can go ahead and create a book with no data, right? It's kind of stupid to do that, so I'm going to go ahead and get rid of that. Let's go ahead and go back over here. I don't care about the default constructor because I'm never going to create a book without a title. I'm never going to create a book without a date read. I'm never going to create a book without an author first name or last name, right? Until those requirements change later on. So that's one consequence, that now that default constructor has gone away. The other consequence is you can go ahead and change this to whatever you want. b.title is equal to null, right? Now, if I were to print this out, what would it end up looking like now? I took that title away. It was Dune before, and now it's null. It's gone, right? Still works. It still prints something out, but it prints null. Should we allow a book to exist with no title? I don't think so, right? Maybe if you could come up with some use case later on, maybe you have an argument for it, but for now, I'm not going to allow that, right? So what I'm going to do is I'm going to come back over here, and I'm going to make the title private, right? I'm going to protect, this is called, I'm protecting my variables from the outside world. Let's come over here, and now I can't do that anymore because it's private to the class. Only the class can see it. You can't see this title from outside the class, therefore you can't change it. I like that so much, I'm going to make everything private. Let's go ahead and get rid of that. I'm going to make everything private in my book class. Right? Once again, I don't like typing, so I'll do it once. Private. Done. Okay? There's one of those little IDE tricks that you should just learn at some point. Oh, except it didn't work on this one. All right, I'll go ahead and get rid of that. There we go. All right, so what did I do? On a Mac, it's Option Command A. That goes into what's called block mode, block selection mode. And you can select a block instead of selecting lines, the entire line, it's now selects blocks like this. Right? For example, if I decided, I didn't want this anymore, you can go ahead and select all that and get rid of it. It allows you to select columns in an IDE, in an integrated development environment. And it is super, super easy, helpful in a lot of instances. To get out of block selection mode, you just do the same thing. For those on a Windows machine, I imagine it's Control-Alt-A, maybe? Find out for yourself, right? Let's see, is there edit? What is it? Alt-Shift-A, there we go. Because again, I'm on a Mac, so Option Command A and Option Command A to go back and forth. Right? Most IDEs will support a block selection mode for ease of typing and selection and stuff like that. Especially data, when you've got columnar data in columns, and you want to just select that column, man, how easy would that be? You usually have to take it over to Excel, and it splits it out into columns for you. Then you can select a column. Well, you don't need to do that with an IDE. You can just go ahead and select it, use block selection mode. Right? All right, well, what if I do want that title? Right? I want to say system.out.println b.title. I really do want to print it out. I'm not going to change it. Right? I'm not going to change it to null or change it to some nonsense. But I do want to access it in order to print it out. Right? That's where what are called getters and setters come in. Right? So public string get title. All you do is take the field name, that is the variable name, title, first name, last name, whatever, right? And you put get in front of it. And that's called a getter. And I'll return this dot, where is it, title. There we go. Right? And now you're perfectly fine over here. But you do have to call that getter function, get title. Right? You do have what are called setters. Right? Public string, or actually void, sorry. Void set title. And here you would actually take a string, the new title. Right? And you'd say this dot title is now equal to that title. Right? That's if you want it to be mutable. Sorry, misspelled string. Right? Remember we talked about strings and how they're immutable. Once they're created, you can't change them. You can make your classes immutable. My book class is no longer immutable anymore. It's mutable because I can change the title. Not a great strategy, by the way, and will discourage you from ever doing this. But it allows you to do other things. For example, all right, fine. You can set the title, but you can never set it to null. What you can do is you can check for that. If the title that you're giving me is null, then I'm going to reject that. I'm going to throw that back at you. Throw a new runtime exception, just like we did when we were handling file I/O exceptions, except now I'm going to give it a different message. You cannot change the title to null, right? So let me come over here and show you this in action. I'm going to violate that. Get the title, b.setTitle null, right? And this is going to end up throwing an exception. A bunch of red text there. You cannot do that, right? It's a way for me to control access to my data in this class. It's even better if you just shut off access entirely. Don't allow any setters there at all. Right? I've got some work cut out for me, right? I'm going to have to do this now for the book ID, the title, the last name, anything that I actually want to use. Or do I? Once again, go up to Source, generate getters and setters. You don't have to generate any setters, just select all the getters. Or you can do all, or you can do a subset. Note here that it's smart enough that it sees that I already did it for the title, right? So it's not going to redo it for me. There we go. Done. All the getters are now there. If you need to get the last name for whatever reason, if you need to get the first name, you need to get the year, et cetera, right? Whole bunch of stuff that you can generate. This is called boilerplate code, right? You never want to actually write this stuff. You just let the IDE do it for you. You can do getters and setters, and by the way, you could have done toString. What does it look like? Well, it just takes everything and concatenates it together, and it doesn't look very nice. But it does give you a starting point if you want to use it. Equals and hash code, we'll talk about those later. Otherwise, constructor, getters and setters, that's basically what you want. Constructor, getters, setters, and toStrings are the ones that you're going to want, especially for your first assignment here. Because you're not going to want to make, you're keeping track of a bunch of transactions. A transaction has an ID, it has an account number, it has a balance before, a balance after, and then an amount, and I think a type. It could be a withdrawal or a deposit or something like that. You need to keep track of all those things. Don't do it with a bunch of just different arrays. Do it with a class, like a book, right? And next time when we come back, we'll go ahead and pull over this code. Sorry, I got rid of my setter there, so I'll get rid of that, right? So I'm going to leave it to do for myself. What I'm going to do is I'm going to take all that code, restore the code that loads the book data, and then we're going to start playing around with it, because I'm going to want it to ask questions. What's the oldest book? What's the newest book? And if I've designed this book class well, right, then it's going to be just as easy as sorting and searching through a bunch of integers. All I have to do is make a comparator. A comparator for books by rating, a comparator for books by author, a comparator for books by year, and it'll do all the heavy lifting for me. Okay? All right. Any questions? No? By the end of the day, you should be at a point where you're loading up data and like putting it all to your like a transaction class of some sort, right? And then you'd be in a very, very good position. If you're there by the end of the day, you're in a very, very good position for Friday. Right? Good luck.